The third question says integrate 3x minus 1 upon x minus 2 x minus 1 x minus 2 x minus 3. Now how do we integrate this particular expression? Once again, the first step, that first thing that you observe is whether the degree of the numerator is less than the degree of denominator. Yes. Whether the denominator has been factorized. Yes. Since first and second are okay, we directly want to convert into partial fractions and then we'll integrate. And in the previous question also we saw some shortcut to discuss the method of the shortcut of finding the values of a, b, and here you will also need c, right? So first let's write the expression in terms of partial fractions. 3x minus 1 upon x minus 1 is there, x minus 2 is there, then you have x minus 3 as well in the denominator. This is equal to what? This is equal to a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. This is what you have. A upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. And for finding the values of a, b and c, we can use a shortcut. But before that, let's solve using the longer approach. Or do we solve with the shortcut first? Let's use the shortcut to get the values of a, b and c, and we'll verify as per the longer approach which is required for NCERT people, right? So let's use this small space. This space is required, yes. So finding the values of a, what do we do? Okay, we multiply by x minus 1 and we put x equal to 1. So these will become 0 and this will go, and a will be equal to, putting x equal to 1, this will be 3 minus 1 upon 1 minus 2 times 1 minus 3. What is that? This is 2 and this is minus 2. So that will become minus 1 upon minus 1. So the value of a is simply 1. B, for b, I'll go a bit faster. So we put x equal to 2, get rid of this. This is 3 times 2 is 6, minus 1 is 5 upon, this is 1 and this is minus 1. This is minus 1 over here. This tells me minus 5. Okay. Value of c will be, putting x equal to 3 over here. This is 3 times 3 minus 1 is 8 upon 3 minus 1 is 2 and this is 1. So this becomes 4. So the values of a, b and c have been found. A equals to 1, b equal to minus 5 and c is equal to 4. But for the NCERT people, for the board people, if you want to solve, we'll have to use alternative approach to get the values of a, b and c. And what is that? So numerators have to be compared. Numerators, 3x minus 1 will be equal to a times, oh, this numerator will be big, right? The LCM will be x minus 1, x minus 2, x minus 3. So will a, you will get x minus 2, x minus 3. Plus b times you will get x minus 1, x minus 3. Right or not? This and this. With c you will get x minus 1, x minus 2. And now do you see that the next step is to get the values of a, b and c by comparing the coefficients, or you can substitute some particular values of a, x, because this is always equal to this. This will be true for some particular values of x as well. Yes or no? Yes. So comparing the coefficients is one of the ideas. The second idea is put some particular values of x. Now putting some particular values of x, isn't that what we have done in the numerator? Yes, in this particular method. That's what we have done without actually using this step, right? So for example, if you wanted a, so what you will do is you will put the value of x as 1. This becomes 0, this becomes 0, this becomes minus 1, this becomes minus 2, which is overall 2. 2a is equal to 2. 3 minus 1 is 2, right? So 2a is equal to 2 implies a equal to 1. This is what you are getting, right? Exactly same thing will come over here. Similarly, value of b, value of c can be found by putting certain values of x. Otherwise, you can also compare coefficients. So compare. Compare tells me coefficient of x square on the right hand side and on the LHS. X square on the left hand side is 0. Okay. So this is a times x square, b times x square, c times x square. That tells me okay, a plus b plus c is 0. That's one thing. Coefficient of x is 3, which is equal to, this is minus 5x, this is minus 4x, this is minus 3x. So minus 5a minus 4b minus 3c is what I'll be getting. This is the next thing. And the last constant term is minus 1, which is equal to 6a 3b 2c. 6a 3b 2c. You see the level of calculations over there? We haven't yet obtained the values of a, b and c. We're just on the path of getting those values, and still we'll have to solve these 3 equations, 3 unknowns. Okay, that looks pretty difficult. Yes, it is not as such very difficult because gradually once you start solving, you'll finally get the values of A, B and C. What you're supposed to do, you can eliminate C first of all, right? C is equal to minus A minus B, and this will convert to 3 equals minus A will become 3A and this will become 3B. So plus 3A, this is 8 minus 5A minus 2A, and plus 3B, this becomes minus B, right? This is what you get. And from here, I'll get minus 1 is equal to 6A plus 3B minus 2A minus 2B. 6A minus 2A is 4A and 3B minus 2B is B. And adding these two will get, will eliminate B. 4A minus 2A will be 2A. 2A is equal to 2 will give me A equals 1, which will give me A equals 1. And that's one thing, A equals 1. Using this A equals 1, and any of these, you can get the value of B. Let's say B will be equal to minus 3 minus 2A. What is this? Minus 3 minus 2, which is minus 5. So A equals 1, B equals minus 5, and using these two, you can get the value of C. So minus 5 plus 1 is minus 4, which will go over there and becomes 4. Therefore, C is equal to 4. So have you found the values of A, B and C using this approach as well? Yes, the NCERT people love this approach. This is A equal to 1, B is equal to minus 5, C is equal to 4, which we found some time back as well, right? So we have verified these values. We are okay with this approach as well. But when we want to discuss the complete steps, we'll follow this approach, right? For the board people, right? Okay. For competitive exams, this is what you'll focus on, and this is how you'll get it done. So the expression has been simplified into partial fractions. Now is the time to integrate. So I, the integral, is equal to 3x minus 1 upon x minus 1, x minus 2, x minus 3 dx, and this converts to integral of a upon x minus 1. A is 1 upon x minus 1. B minus 5 upon x minus 2 plus C, which is 4 upon x minus 3 dx. And this integral can be separated out. This integral of this will be log of modulus x minus 1. Minus 5 goes away, 1 upon x minus 2. The integral will be log modulus x minus 2. 4 goes outside, integral of this will be log modulus x minus 3 plus constant of integration. And yes, that is the required answer for this particular question, as you can see over here. Mind you, the important thing, this method involves first finding partial fractions, and that is the calculation for that. Actually, this is the calculation for that. Right or not? Yes. And once you are experienced enough, you can directly move from this stage to this stage. Yes. You can find the values of A, B and C orally as well. Yes or no? Yes. So this is the third question for us, and that's a complete solution for this particular question.